In question number 17, we're going to take a look at structures that can actually support the formation of a chiral carbon. So we're first given the condition that we're dealing with ethers that come with the general formula of ROR, whereby R1 and R2 are hydrocarbon groups, or you can just interpret this as your alkyl groups. Now we're now looking at the minimum number of carbon atoms that we must have in an ether molecule that allow us to possess a chiral carbon. So the chiral carbon itself, just as a little bit of a revision, must have two mutually inclusive criteria. There must be the presence of an sp3 hybridized carbon. So an sp3 hybridized carbon is, very simply put, an alkane itself that has a total of 4 covalent bonds that's being extended. And the next criteria is that it must have this particular carbon to be attached to 4 different substituents. They should not look the same. So in this case here, going for a total of 4 carbon, I'm going to start off first with CH3 bonded towards oxygen. Now I'm going to have a total of 3 more carbons I'm going to deal with. So I can have a linear carbon chain of a CH2, CH2 and CH3. This will not do us any good because there will not be any of your chiral carbon. So what I can do next is that I can try to form a branch isomer, CH3O. I'm going to have a C with a CH3 with another CH3 and it has another hydrogen. Now at the first glimpse here, we have 1 substituent, 2 substituent, 3 substituent. However, my next methyl group here is exactly like this methyl group, and therefore it is unlikely that for A, we can actually generate any form of your chiral carbon. So going over to situation B over here with a total of 5 carbon, we're going to have a CH3 oxygen. So straight up, we know that there's no point going for a linear conformation. So let's just try out with branches. We're going to have a carbon with a CH3, with another CH2, CH3, followed by another hydrogen over here. And based off this, you can see that definitely there are 4 different substituents. I have 1, 2 methyl, I have an ethyl, and I have a hydrogen. And this generates your chiral carbon. Now 5 is the minimum number. If you go on to 6 and 7, definitely you have no issues in generating your chiral carbon. But again, the question wanted us to go with the lowest number, and we should be going with B as your correct answer.